7.0 Universal Gravity. As described in other lessons, gravity is a force of attraction between any two objects with mass, such as the attraction between you and the Earth and the Moon, and the Earth and the Sun, and beyond. Universal gravity is the fact that the gravitational field created by an object extends throughout the universe. Even though an object's gravitational field strength falls off or diminishes with distance, it does extend infinitely outward and will affect any other object with mass with its gravity, however small. These two objects each have mass. Mass 1 is much smaller than mass 2. However, the fact that these two have masses at all mean that they will have each experience a force attraction to one another. Now it seems that mass 1 would be attracted by mass 2. However, mass 1 also attracts mass 2 with equal magnitude force, only in the other direction. This is based on Newton's third law, that states that for every force, there is an equal but opposite reactive force. Newton's second law describes the relationship between forces, mass, and acceleration as F net equals ma. Therefore, the larger mass on the right accelerates less than the smaller mass on the left. This is also seen when you jump on Earth. The force attraction between you and Earth is felt equally by you and Earth. However, the fact that the Earth is so massive, you noticeably accelerate downwards, while the Earth does not seem to accelerate upwards at all. The formula used to find the gravitational force between two objects is F sub g equals big G times mass of one object times the mass of the second object, divided by the straight line distance between their centers of mass squared, often referred to as the radius. G is a special value called the gravitational constant, and is a value of 6.67 times 10 to the negative 11 Newton meters squared over kilograms squared. M1 and M2 are the two masses measured in kilograms. R, again, is the center-to-center distance in meters. Any two objects are attracted to one another in a straight line that joins the two centers. As you travel away from Earth, the radius will become larger in the denominator, which results in a smaller field strength. That is, gravity falls off or decreases with increased distance. This is also true if you're on a planet that has a smaller mass or a smaller radius, like the Moon, where it's about 27% the radius of Earth, and only about 1.2% the mass of Earth. This results in the Moon's gravity being 1.6 meters per second squared, roughly 1/6 that of Earth's.